Okay, students of geometry, now that you are aware of central angles and arcs, we're going to talk about inscribed angles today, a different kind of angle. Okay, remember, as always, if there's anything you don't understand or you're not sure about, please ask me. Please get some help with it before we keep moving on, okay? So today we're going to talk about the relationship between an inscribed angle and their arcs. Getting ready for the lesson, there's a little information here. What is an arc? You know that already, but it's here again. An intercepted arc is the arc formed when segments intersect portion of the circle. A chord is a segment who's inside the circle, whose endpoints are on the circle. So a radius is not a chord. Okay? And an inscribed angle is an angle whose vertex is on the circle and whose sides are chords. So the difference between a central angle and an inscribed angle is this vertex is not at the center of the circle anymore. It's on the circle. It's one of the points of the circle. Okay, so angle ABC is an inscribed angle. And the arc that corresponds with that is arc AC. And there's some examples here. The center of the circle is on the side of the inscribed angle. It could be inside, outside, or right on. It doesn't matter where the center is for an inscribed angle. Okay, so this first question is leading you to kind of discover the relationship without me just telling you what it is, okay? So my first question is, what type of triangle is triangle BDC? What type of triangle is that? Now you might look at it and say it's obtuse because it looks like angle BDC is greater than 90, but and that probably is true. Actually, CDB is 112 if you look right here, so that is true. It is obtuse. But more importantly, okay, the triangle has two sides that are radii, right? D to C is a radius and D to B is a radius. Radii is the plural of radius. So now that I marked it up, I know you know that this is an isosceles triangle. Because all radii of the same circle are congruent. AD is also congruent to DC and DB. Okay, if we know that angle CDB is 112, could we find the measure of angle DBC where the X is? Well, yes, not even looking at the circle arcs or anything, ignoring all of that, we could say with an isosceles triangle, these two angles, the base angles have to be congruent. So if we do 180 minus 112, take that answer and share it between angle B and angle C, we get 68. 68 divided by 2 is 34. They're each 34 degrees for angle DBC, and DCB is 34 degrees. Okay, now, what is the measure of arc AB? So now we're going to relate it to the arcs. AB is going all the way around here like that, or the other way. They're the same each way, and it is, we all know that, halfway around 180 degrees. What is the arc BC? Well, BC arc is inscribing this central angle 112, so this arc has to be 112. Now you might say to me, oh, well, Mrs. Marino, this angle is cutting into the arc AC right? You can see that, can't you? And it's 34. No, it's not 34 because this is not a central angle. We can use the 180 minus 112 that we did right over here for our triangles. You're using it again here and you're getting 68 here. So now the question is, what is the relationship between the inscribed angle and its intercepted arc? The arc here, I'm going to change colors so you can see, is 68. And the angle here is 34. Maybe this can give you a hint as to what the relationship is. They're not equal. Okay? The measure of the angle is 1/2 the measure of the arc. Okay? And vice versa, the arc is double the angle, the inscribed angle. Sorry, the phone's ringing. Someone else will have to take care of that. Okay, here's another, here's a little link for you to look at. There's a little something there for you to see. Let's see. I don't think it opens when I'm recording, so you can open there and explore in GeoGebra. Okay, discover problem number 2. What's the intercepted arc of angle RUS? So let's find angle RUS, R to U to S. That's the 31-degree angle. Okay, what arc does it intercept? Well, where does it cut into the circle? So you're going to look for this arc, SR. And then I'm just going to erase my highlights here so I can refocus. What is the intercepted arc of angle STR? STR is over here. What is the intercepted arc for that angle? Also, SR, because it cuts into the circle here. It might take a little while for you to practice highlighting to see where the angle cuts into the circle and what the intercepted arc is for that angle. Okay? So what's true about those, they intercept the same angle. So what's true about them? They're both half of that angle, so they have to be equal. Angles that intercept the same arc must be congruent. Okay, so here's just a little fact sheet for you. You have your central angle, your intercepted arc, and your inscribed angle. And here's some problems for us to work on, okay? Here you're going to say, okay, the angle is half of the arc. So do 124 divided by 2 is 62. Okay, now here, the angle is half of the arc. So if you know the angle, you don't divide it to get the arc, you have to double it. So it's 96 times 2, which would be 192. All right, now here's where they get a little tricky. Find the value of x. So we want to know what this angle is, the central angle, okay? And what do we know? We know that this angle, the inscribed angle, is 32. What is the arc? Remember, the angle is half of the arc. So to get the arc, we double. And then the central angle equals its arc, so x is 64. This is going to take some time. Go slow. Inscribed angle is half of the arc. Central angle is equal to the arc. So we're combining the last two things that we did. find the value of x. X is an inscribed angle. It inscribes this arc. If I knew this arc, I could half it and get that angle. The only thing I know is this angle, 25. That's half of the arc it intercepts. So this arc is 50. And then this angle is half of that arc. So x equals 50. Trying to think. I'm trying to look, just see where else we're going here. Okay. Find the measure of arc QR. So we're looking for this piece. I try not to put variables on stuff here. I just try to highlight what I need and then I'll figure it out. What could I figure out here? All right. Well, I have an inscribed angle as half of its arc. So if you take this 50 and you extend where that angle, where it cuts into the circle, and double the 50, you get 100 right here. Okay? And this is actually a diameter because of that point. And so it's cutting the circle in half. So the arc we're looking for right here has to be, I think you can figure that out. If you don't understand what I'm doing or I'm going too fast, you can always stop and slow the video down and do one thing at a time. It might be best to do a problem and see my video, do a problem, see the video. Okay? I'm going to do a little bit. Let me just keep going. I'll just keep going through them all. In the accompanying diagram, BA is a diameter. Okay, so we got a 180 here and a 180 on the other side. Measure of arc BC is 50. They want us to find this angle. That's a question mark. It doesn't look like a question mark. Sorry. Okay, so what could I find out? I could find out this arc. 180 minus 50 is 130. And then the inscribed angle is half of the intercepted arc. So 130 divided by 2 is 65. And the measure of arc ABC. Now here's a 3-letter arc. It means from A to C but going through B. This is a major arc. Is 150. So back from here to here is 150. I can find out the other piece. 360 minus 150 is 210. This is 210. Because all the way around the circle is 360. Okay, now what is the measure of this angle? That's an inscribed angle. Half of the arc. So 1/2 of 210 is 105. In the diagram below, with diameter BC, okay, diameter BC, important, that cuts it in half. You have parallel chords. So parallel chords, something very important is happening. When chords are parallel, I don't know if we need to know it for this, but they create congruent arcs. And the arcs between them are congruent. Those two arcs are congruent because they're the same distance apart from each other. So their arc across from each other have to be equal. The measure of angle BCD is 30. BCD, I have to find it right. Find that angle, BCD. That's over here. Stay still. 30. Okay. Determine and state the measure of angle AOB. We want this angle. This is what we're trying to find out. Okay. If the inscribed angle is 30, the arc is not 30. Only central angle equals its arc. The inscribed angle is half of the arc. So if the angle is 30, the arc is double 60. Now, I have a diameter That makes it cut into 180. If that is 60, this is 120. I think you need to know the fact that these two arcs are equal 60, making this one 120, right? So that gives me 360 going around. Is that 360? 1, 2, 360. Yes. Okay, now, what are we looking for? I didn't mark what I was looking. Oh, yeah, looking for that central angle. Got it. Central angle is equal to its intercepted arc. So angle AOB is equal to 120. Hope you can see that color. It's not a great color to be writing with. I don't know what I'm doing in that department. The accompanying diagram of circle O, the measure of angle ABC is 2x, and the measure of arc AC is x plus 60. How do I know it was that arc and not the other AC? The other AC is major. It would have to say major or ABC. It's always the shortest distance. Okay, now, they're not equal. Don't write them equal to each other. Some kids will do this. That's incorrect. Let's make it red. No. Angle equal arc is for central angle. This is not a central angle. Okay? So this is wrong. What are we supposed to do? The angle is half of the arc. Inscribed angle now my phone is ringing. Sorry. Inscribed angle is 1/2 of the arc it intercepts. Okay, so 2x is 1/2 of x plus 60. Now you might not like that 1/2. Okay, so what you could do is you could say, all right, I want to take that and multiply both sides by 2. And I want to say double the angle is equal to, this will be gone, the arc. That might be easier to solve. Now I get 4x equals x plus 60 minus x from both sides. 3x equals 60 and x equals 20. Let's put those numbers in and see if it makes sense. 20 times 2 would be 40. So this angle is 40. Then the arc has to be double the angle, 80. 20 plus 60 is 80. So it worked. All right. Here's another one of those ratio questions. Okay? Remember, you have to line them up. So DF is first. It goes with the 5. And I put an X in. 5X. FE is 2X. EG is just X. 1X. And GD is 7X. All together, they add up to 360. It's 15x equals 360. Yes, divide by 15. 360 divided by 15 is 24. X is 24. Okay? You could put them back in and get the arcs. Once you get the arcs, you can get the angles. But look at what this is asking for. Identify one pair of inscribed angles that are congruent to each other. Inscribed angles are congruent if they intersect the same arc. So if you find an inscribed angle like a DFG, what's another angle that intercepts the same arc? Let's change the highlighter to blue. Has to hit here and here. How about that angle? They both intercept the 7x, so they'll be half of 7x, 7 times 24. There's another pair there. If you change your view somewhere else, use another pair of inscribed angles that intercept the same arc. All right, so what was the mistake here? This says that the angle ABC is 53 degrees and the arc is 53 degrees. What's the mistake? I think you know. Angle ABC is not a central angle. Only a central angle equals its arc. Okay? So to find the arc, when you have an inscribed angle, you have to double the angle. Okay? And I've attached the problems for you here to do that go along with this. All right? So that's my video on inscribed angles.